Imagine you are trapped in a dark cave. You cannot see the outside world. You only see shadows flickering on the wall. This is the condition of the econometrician. We want to understand the hidden laws of reality, but we can only observe the data left behind. Regression analysis helps us make sense of these shadows. The shadow we are trying to predict is the dependent variable, or the regressand, denoted by the letter Y. The light casting the shadow, the cause we can actually measure, is the explanatory variable, or regressor, denoted by the letter X. For example, if we want to predict a family's consumption expenditure, consumption is our Y, and income is our X. Regression finds the mathematical thread that binds the light to the shadow. But where does this word come from? In 1886, scientist Francis Galton discovered that children of exceptionally tall or short parents tended to move, or regress, toward the average height of the entire population. The word comes from the Latin regressus, meaning a return, or stepping back. Regression is simply the journey back to the average. It studies the dependence of one variable on another. To find the average response, to connect the cause X and the effect Y, we seek the ultimate truth, the population regression function, or PRF. It is the God's eye view of reality. The equation is written as the expected value of Y given X equals beta 1 plus beta 2 times X. But what are these Greek letters? They are the fixed, unobservable parameters of the universe. The word originates from the Greek para, meaning beside, and metron, meaning measure. They are the invisible rules measuring reality from alongside it. Beta 1 is the intercept, the baseline. Beta 2 is the slope. It tells us exactly how many steps Y will take, for every single step X takes. And here is a crucial secret. When we call this a linear regression model, we do not mean the world is a straight line. Econometrics only requires linearity in the parameters. The beta symbols can never be squared or raised to a power. Human behavior can curve and bend, but the mathematical rules governing the parameters are absolute. But reality is never a perfect equation. An individual family's behavior will never sit perfectly on our average line. Therefore, we must add one more symbol to the true equation, plus U. This U is the stochastic disturbance, or the error term. The word stochastic comes from the ancient Greek word stokos, meaning a bullseye, or target. We aim for the absolute truth, but human behavior is filled with random misses. As Milton Friedman noted, all good theories oversimplify outrageously. We add U to represent all that oversimplification. It is a surrogate for every hidden variable we forgot to measure. The vagueness of our theories, and the intrinsic chaotic randomness of human free will. The golden line is the mathematical rule, but U is the messy reality. Here is the tragedy of economics. We can almost never see the true population line, because we rarely have data for the entire population. We only ever hold a tiny, random fragment of reality, called a sample. From the old French sample, meaning a specimen to be tested, to survive in the dark, we build a proxy called the sample regression function, or SRF. Because we are blindly guessing the ultimate truth, we place a mathematical symbol over our letters, a little roof, called a hat, Y hat, beta 1 hat, and beta 2 hat. Whenever you see a hat in econometrics, it is a confession of ignorance. It indicates that the number is merely an estimator, our best mathematical guess, based on the limited fragmented specimen we happen to hold in our hands. Because our sample is just a guess, our flickering estimated line will rarely hit the actual data points perfectly. There is a gap between the actual Y values and our estimated Y hat values. This gap is called the residual, denoted by U hat. The word comes from the Latin residuum, meaning that which is left behind. Just as the original U is the unobservable error of the entire universe, U hat is its sample counterpart, the measurable error left behind by our specific guess. The entire goal of econometrics, using the famous method of ordinary least squares, is to draw our line so that these residuals, these shadows left behind, are as small as humanly possible. We cannot know the absolute truth, but we can draw the best possible shadow.